Hey guys, in this video we're going to take a look at Chapter 4. We're going to look at sequences, and we're going to first talk about convergence. In the next video we'll look at a few examples where we prove some convergence. But let's first define a sequence. So what is a sequence? A sequence is a function whose domain is the set of natural numbers. Right? And so you can write a sequence notationally like this or like this. So we have a couple ways we could write that sequence. There's actually probably several others, and so we'll explore those a little bit in these examples here. And so let's take a look. In this first example, let's write out the first four terms of this sequence. Right? So this sequence has a domain that's the natural numbers. The codomain is the real numbers. And what this function s is going to do, what the sequence is going to do, is for each natural number, it is going to associate 2 times that natural number. So this sequence is going to be when n is equal to 1, we have 2 times 1, which is 2. When n is equal to 2, we have 2 times 2, which is 4. And then 2 times 3 is 6. And then 8. And it continues on. And so that's what that would look like. In terms of a graph, 1 is associated with 2. 2 is associated with 4. 3 is associated with 6. Right? And so that would continue on. For this next example, if we were to take a look at it, we have 1 over 3n, and so this sequence, when n is equal to 1, we have 1 over 3 times 1, which is 1/3. When n is equal to 2, we'd have 1 over 3 times 2, which is 1/6. When n is equal to 3, we'd have 1 over 3 times 3, which is 1/9. And then 1 over 3 times 4, which is 1/12. And so the graph of this is going to be when we have 1, we are at 1/3. And when it's 2, we are at 1/6. And then 1/9. Right? And it keeps going down. It's monotonic decreasing. Yeah. Our next example, we have when our value of n, so here we're starting with n is equal to 2. It's going to go from 2 to infinity. And so when our value of n is 2, the first term in the sequence is -1 squared, which is +1, over 2 to the second, which is 4. 2 squared is 4. The next term in the sequence would be when n is equal to 3, so -1 cubed, which is -1. 2 to the third power, which is 8. And so 1/4, -1/8 is the next term, then 1/16, and then -1 over 32. All right, so as our value of n goes up, our denominator is being multiplied by an additional 2. Our numerator is being multiplied by an additional -1, and so it's going to alternate signs. All right, and so this graph is going to look like when we have n is 2 out here, we're at 1/4. When n is 3, we're at -1/8. And then 1/16. And then -1 over 32, right? And so it's going to just bounce back and forth. But slowly, looks like maybe it's zeroing in on 0. It's getting closer and closer, right? And so we know from calculus, or we have this idea of convergence, right? And so we'll formally define that here. Right? So we say a sequence is said to converge to the real number s, provided for every single choice of epsilon that's greater than 0, there exists a natural number, big N, in the natural numbers, so that no matter what value you choose, other value in the natural numbers that you might choose, provided it is large enough, then the difference between the nth term in the sequence and the value that we think it's converging to is going to be less than epsilon. Right? So when our values for the sequence, so when we get arbitrarily large, arbitrarily far down the sequence, then we are going to get arbitrarily close to S. If that sequence converges to Sn, if that sequence converges to S, then we say that S is the limit of the sequence. We can write it in lots of different ways. If a sequence does not converge, then we say that it diverges. And so that's our first video. So on the next page, in the next video, we're going to take a look at some examples.